Welcome back, geometry students, to 9.6 dilations, which is going to be the final section we go over in chapter 9, which is concerning, chapter 9 concerns all different types of transformations. And this is the last one. So a dilation, when you hear the word dilation, I'm betting the first thing you think of is your eyes. The center part of your eyes dilating, your pupil, okay? So we think of a dilation, let's just draw your eye real fast. I know it's not a particularly beautiful eye I'm drawing, but what happens when we have a dilation? Well, a dilation is, for example, you go into the doctor's office or whatever, and your pupils dilate. That means, let me redraw this, that means they get bigger. Now, and we're talking about geometry. Oops, the eye needs to stay the same size. So dilation in regard to your eye generally means that it gets bigger, okay? So a dilation is a change in size. A change in size. Okay, so it's a growth or a decrease. So when we think about dilation, we don't often think of your eyes dilating to become smaller, but it is a change in size. So one of the first conditions of a dilation is that they need to preserve angle measure. So preserve angle measure. So if we're looking at these two shapes right here, well, let's label this one. Let's label it P prime, Q prime, and R prime. Okay, so if we're looking at these two triangles, you'll notice that these angles are the same measure. Okay, so that's one of the key features. So the second thing, all right, so the size of the image is a scale factor difference. Okay, what do I mean by that? Well, let's take the distance here from our, let's call it point O. This is our origin point. This is our point of that we're expanding our dilation, our center of dilation. Okay, so let's go ahead into center of dilation. This is a point at which the scale factor is applied and shape dilation occurs. Okay, so this is our center. This is how we're going to measure our scale factor. So our scale factor here is we're going to take point P times our scale factor, and that will equal P prime. So our scale factor times P will give us P prime. And this is going to be useful for when we're on the coordinate plane. But a scale factor thing, we heard this before when we were talking about similar triangles. Remember, if they have three congruent angles, they're similar, okay? But remember, if it's changing in size, it's no longer congruent. So this is not rigid motion. Okay, this is not rigid motion because the size is changing, okay? However, it does keep a symmetrical and a similar shape. The only difference is it's being multiplied by a scale factor, okay? Now, scale factor is a factor of growth or of shrinking. So what do I mean by that? Well, if we're talking about enlargement, okay, so if we're enlarging a shape, so this purple is our image. So the purple is our image and our pre-image, sorry. And the blue is our image. And this is for both these examples. So blue is going to be our image. Okay, so enlargement. That is when we have a scale factor who is bigger than 1. Okay, so a scale factor bigger than 1. That means, let's say the side of this shape is 2 centimeters. Okay, and let's say our scale factor is 5. Well, our new, well, that doesn't look like 5. Let's change it to 3. That's a better one. So our scale factor is 3. So our new side length would be 6 centimeters, okay? So that's what the scale factor means. So 2 times 3, our scale factor, gives us 6. And it's growth, it's enlargement, and that's clearly scale factor 3 is bigger than 1, okay? Now notice how if, depending on where the center of the dilation occurs, this is the center of dilation, notice how the shape enlarges around that. So if the center is on a vertex of it, the enlargement happens away from that vertex, okay? It happens away, so you grow around it or away from it, okay? Let's compare this to the second example, okay? Notice how the center of dilation is in the middle, center of dilation. Okay, now notice also that our pre-image is the big one, and our image is the small one inside. Okay, what's this case? Well, this is in the case of a reduction. Okay, I put shrinking. Shrinking is the same thing as a reduction. And this is when we have a scale factor between 0 and 1. Okay, so you're thinking a fraction, you're thinking a decimal, but that's what's going on. So let's say this length right here is 10 centimeters. Well, if the scale factor was 1/2, we undergo a transformation, a dilation with a scale factor of 1/2, this would become 5 centimeters. So that would be our scale factor for this square's transformation. Now, notice how if the center of dilation is in the middle, that everything gets shrinked, gets reduced towards this center. Okay? So if we were going opposite and the blue was the pre-image and it was getting enlarged, notice how everything would get enlarged away from the center of rotation. Okay, so the center of rotation, everything either expands away from it if it's an enlargement, or if it gets reduced towards it. It's like a black hole if it's a reduction, or it's like tsunami winds if it is an enlargement. Okay, everything gets pushed or blown away from it. Now, the notation, this is at the origin. And for this course, we're only going to be talking about dilations at the origin. Okay, so how do we notate it? Well, with all the other shapes, we used the letter. We made it simple for ourselves. So we used the letter at which we were expanding. So D is the letter for the dilation. Okay, so D stands for dilation. So let's go ahead and write that. This is dilation. Okay, now the next thing we need to write is N. This is the scale factor. So N is the scale factor. So whatever number that is, that's probably going to be a number. It has to be. So the scale factor is going to be a number. Okay, so we're going to find out what our scale factor is. And then we have the point. The point or the shape that we are dilating. Okay, so with dilations, you really have to do it one point at a time, just like we did before. So it could be a shape. So whatever our image is. So let's go ahead and put pre-image in parentheses. And that's at the origin. Keep that in mind, okay? Low battery, challenge accepted. Now, final example, sorry. Actually, we got 2 examples here. I probably will just do another video for example 2, just so you guys can keep it short for this particular one. Okay. So what are the coordinates of D2 PZG? Okay, let's break this down. D stands for dilation. So we know we're going to be dilating. 2 stands for the scale factor. So we know we're going to be multiplying by 2 to our pre-image. And then P, ZG, this is our pre-image. Okay. So how do we do this? Well, the first thing we need to know is we need to know the coordinates. Okay. We're not going to be measuring these side lengths and then multiplying by 2, and then who knows what we're going to do, okay? So what we're going to do is we just need to label these coordinates. So let's label this one as -2, 1. Let's label this one as 0, -3. Let's label this one as 2, -1. Okay, so how do we apply the scale factor here? Well, to apply the scale factor, sorry, I want blue. To apply this scale factor, we're just going to take each coordinate. So Z is -2, 1. P is 2, 1, -1, sorry. And then G is 0, -3. We are just going to take each one of these coordinates and we are going to multiply it by the scale factor. Well, how do you multiply by a scale factor, you may ask? All you do is multiply each one of the x's and y's by the scale factor. So what becomes our new point? Once we, oh, sorry, I'm having a little difficulties getting to the edge here, so we're going to separate it. We're going to have our social distancing 6 feet away from each other. Okay, so now we multiply -2 times 2, we get -4. We have 1 times 2, and that's 2. So now our z, after we dilate this image, keep in mind it needs to move away from the origin. All this is about the origin for now. So we go to -4, 2. This is our new location, which we will call z prime. Okay, what's next? We're going to do it the same thing for p. We're going to multiply by 2 times 2, which is 4, and -2 times 2, -2. That is p prime. So a new location is 4, -2. P prime. Now we're going to go to G. We're going to do the same thing, times by 2. We get G prime. And that will become 0 times 2 is 0. -3 times 2 is -6. G prime. We're going to connect our dots. And with all this in mind, boy, this bothered me a little bit. We got to fix it. With all this in mind, we have a shape that is expanded around the origin. Okay, so the dots move further away from the origin, and it's enlarged, and it is exactly twice the size of the original shape. This is how you do dilation. Stay tuned for next time where we go over a great problem, which would be something that you would see for an honors test. See you next time.